Hi, I'm Andrew Connell, and I'm a Microsoft MVP in the area of Microsoft 365 development. And I have a lot of experience with SharePoint development, including all of the different development models that we've had, Microsoft Graph development, Microsoft Teams development, and developing add-ins for Microsoft Office, as well as working with Microsoft Identity, including Azure AD. Microsoft Graph provides a unified programmability model that you can use to build apps for organizations and consumers that interact with the data of millions of users. Microsoft Graph APIs implement many of the OData protocol's query parameters, and in this module, you'll learn how to manipulate queries using query parameters. We're going to first start with an overview of the Microsoft Graph and then understand how to access Microsoft Graph. We'll then move on to talk about manipulating responses with query parameters, controlling the amount of information returned in queries, and manipulating the order in the format the data is returned. Microsoft's Office 365 developer vision focuses on the user's experience and their data. As a developer, you can bring your applications into their user experience. With over 1.2 billion users of Office worldwide, this is a huge opportunity to provide a window into your applications, as well as being able to connect into their data and add intelligence to your applications. There are currently 850 million events created a month and a total of 470 petabytes of data or more in the service that can add value for your users. Microsoft Graph is the gateway to your data in the Microsoft Cloud, as you can see from the list of resources, services, and entities on this slide. There are lots of things that you can take advantage of in the Office 365 platform. You can work with mail, calendar, contacts, tasks, in addition to content inside of SharePoint sites and lists, files inside of OneDrive, and interact with Microsoft Teams and many more things that you can take advantage of. Each of these services typically has its own API that you can leverage to read and write to these different services. However, it can be challenging and cumbersome to work with these different services as each has implemented their own endpoint, permission model, and syntax for performing some operations like searching and other subtleties. Each endpoint is also secured with Azure AD, which means that developers will need to authenticate with Azure AD and obtain an OAuth access token for each service they want to work with. The Microsoft Graph addresses many of these challenges by acting as a proxy to a lot of the different services. It encompasses data residing in Office 365, such as mail, calendar, and contacts, and OneDrive, as well as many others. In addition, it also provides access to Windows 10 and enterprise mobility and security under a single endpoint. This endpoint, https://graph.microsoft.com, allows developers to create applications that will only have to authenticate once and obtain a single access token that can be used to retrieve data from multiple sources, greatly simplifying the development process. Each service will still have their individual permissions or scopes, but all of these permissions are defined in a single place under the Microsoft Graph endpoint and handles the underlying calls and permission requests to each of these different endpoints. As the previous slide stated, the Microsoft Graph is your gateway to all data in Microsoft 365. It is a single resource that proxies multiple Microsoft services. Because the Microsoft Graph acts as a proxy endpoint to multiple endpoints for each Microsoft 365 service, it will simplify the process of obtaining OAuth access tokens that you must include with each request to one of these endpoints. Unlike the process of obtaining a different token for each endpoint, the Microsoft Graph enables you to obtain a single access token to submit requests that can retrieve data from all the services and endpoints that the Microsoft Graph exposes. One of the challenges we used to have to deal with these different services was determining the endpoint URL for each service, as some of them were unique to each user. To address this, Microsoft created a directory service that you could query to determine what the URL was for the different services for a particular user. However, the Microsoft Graph greatly simplified this with two special endpoints, the /me and the /myorganization endpoints. These will take you to the root of your user entity or your organization within the Microsoft Graph. This module will explain how you can easily find relationships between entities in the Microsoft Graph and traverse these objects to find related content.
Using the /me and the /myOrganization endpoints in combination with the ability to traverse related entities, the Microsoft Graph makes it easy to access your data. Developers can create all sorts of applications that will communicate with the Microsoft Graph. And to support as many developers and as many platforms as possible, the Microsoft Graph has two options for developers to choose from when integrating the Microsoft Graph into their applications. At its core, Microsoft Graph is a REST API. This means that developers can use any platform, any framework, and any programming language they are most comfortable with. The only requirement is that they issue a common HTTP request and process HTTP responses, which pretty much all relevant platforms and frameworks and languages can do these days. In addition, Microsoft Graph also provides native SDKs for developers who want to leverage a rich programming model with their applications. These SDKs are available for multiple platforms and simplify the process of interacting with the Microsoft Graph REST API, abstracting away the tasks of constructing, submitting, and processing the REST requests and responses with Microsoft Graph APIs. You will likely find an existing SDK for the platform and language that you are working on, as you'll find almost all of the popular platforms are covered, including .NET, iOS, Android, Java, PHP, Ruby, JavaScript, and many, many more. Microsoft Graph supports two styles of authentication. One supports the users to authenticate using either Azure AD accounts, which are also known as work and school accounts, or a Microsoft account. The former account is typically used to access content and resources within other Office 365 services and Microsoft 365. The latter account type, a Microsoft account, is used to access consumer services such as OneDrive Consumer, Outlook.com, and other related services. Now, what's nice about Microsoft Graph supporting both styles of authentication is that the same API and the same endpoints can be used to create applications that will expose business data to Microsoft in Microsoft 365 or consumer data within the Microsoft Consumer Services. This makes it easy for developers to learn a single API and have the ability to configure their application to support both businesses and consumer data that is driven strictly by the user and what type of account they're going to log in with. Microsoft Graph REST API confirms to the OData v4 protocol. Now, one aspect of this is that the REST API supports many query parameters. These query parameters enable developers to specify and control the amount of data returned in the responses. Each endpoint exposed by the Microsoft Graph has varying support for different query parameters. For example, the count query parameter is supported by the context endpoint, but it isn't supported for directory objects like users and groups. Microsoft's query parameters are added to the query string portion of a URL and have a $ prefix. Each parameter has a different syntax for its usage. For example, the count query parameter, when set to true, will tell Microsoft Graph not only to report the number of items in the collection instead of returning all the data in the users. This dramatically reduces the amount of data returned by the service, reducing the work on Microsoft Graph and bandwidth consumed by your application. One of the most powerful uses of query parameters is to control how much data is returned in the request. The $top parameter enables you to limit the response to only include a specific number of records, while $skip enables you to skip the first number of results in a response. You could combine the $top and $skip parameters to implement a paging solution. For example, consider the scenario where you want to display 5 items at a time. Page 1 would only include $top equals 5, while page 2 would include $top equals 5 and $skip equals 5 to skip the first 5 results that were shown on page 1, but get the next 5 records to display. Some queries against Microsoft Graph return multiple pages of data due to server-side paging or due to the $top query parameter to specifically limit the size of a request. When a result spans multiple pages, Microsoft Graph returns a special property called at OData.nextLink property in the response that contains a URL to the next page of results. For example, in the following URL, all the users in an organization with a page size, it'll return a list of all the users in
in an organization with just the top 5 specify with the $5 query parameter. If the result contains more than 5 users, Microsoft Graph will return a next link property similar to the same query that you had, with the additional paging information that it would need to get the second page of information. You can retrieve the next page of results by sending the URL value of the @odata.nextLink property to Microsoft Graph. Microsoft Graph will continue to return a reference to the next page of data in the next link property with each response until all the pages of the result have been read. Microsoft Graph responses will include a set of defined properties with no result set is defined. This means that you only want to display the name and an email address of a lot of users. You can actually receive a lot more data that isn't going to be used. To optimize the request and the response, you can use the .select query parameter to specify a comma delimited list of the properties that you want to receive within the response. Another powerful use of query parameters is to control how the data is returned in the response to a request. The ordered by parameter enables developers to let data from Microsoft Graph be pre-sorted. By default, data is returned in an ascending order, but you can add the DESC keyword after the property to sort in descending order, and it also supports sorting by multiple fields, separating each field with a comma. Complex fields can also be sorted. Complex types, such as the from field in an email message, is a complex type of email address that contains both a name and an address property. To sort by name, just use the from/email address/name property. By default, responses from Microsoft Graph are returned in a JSON format. However, if you want the data to come back as Atom or XML, you can do that by defining and specifying the $format query parameter and setting it equal to one of those values. Now in this first demo, we have a .NET Core console application that we've created. We're going to take a look and manipulate some parts of it to explore how to work with the Microsoft Graph query parameters. In order to call the Microsoft Graph or make a request to the graph, we have to submit an access token, which means that we're also going to need an Azure AD application. So that's the first thing that I'm going to do is I'm going to create an Azure AD application. I'm going to go with more of a simplified approach with this because I want to focus the demo not on the authentication part of working with Microsoft Graph. Instead, we're focused on the query parameters itself. So we're going to do a shortcut or two here. So I've logged into the Azure Active Directory Admin Center. I'm going to create a new app by selecting Azure Active Directory and then pick App Registrations. And I'm going to give my new registration for my new app, just call it the Graph Console app, and we're just going to work with a single tenant. I don't need to worry about the other options. So I've gone ahead and created it. Now we see we have an application ID. We've got a directory tenant ID as well. We're going to need those a little bit later when we configure the .NET Core console app. But for now, let's just go ahead and grant our application some necessary permissions that we're going to need. Now our app is going to fetch users from Microsoft Graph. And so to do that, I need to give it a permission to go get all my users. So I'm going to go to the API permissions and add a new permission for Microsoft Graph, and it's going to be an application permission. And because I want to get all the users in my organization, I'm going to choose the user.read.all scope, and that's going to allow me to find all of my users inside of my organization. So go ahead and hit add permissions. And you can see here that it requires admin consent. So just to keep things simple, I'm going to go ahead and grant the consent right now and not have to go through the consent flow to get that working when I go to use my app. Now let me come back over. Let's go look at our application that we've created. So what does this application do? So let's look at this from a high level here. And there's a lab associated with this screencast that walks you through the process and step-by-step detail of creating the same app. Instead, I just want to focus in this demo on what the app does. So what it's going to do when it first runs, it's going to say hello world, and then it's going to load the settings for my application. So that's a utility function we have that's going to be fetching these settings for our app. So you can see here we've got a tenant ID, our app ID, a secret, and a redirect URI that we have listed here. So we need to go through and go grab these things. So let's go back over to our Azure AD app and let's do this right now. So if I go to the overview of my app, we have the client ID. So let's copy that and we'll paste that right here. We need the tenant ID, or otherwise known as the directory ID. So I'll grab that and I'll paste that in. We're also going to need an application secret. So let's go create that secret. So I'll come over here to certificates and secrets. We'll create a new secret. This is just going to be called temp. It's good for a year. That's fine. And once it's been created, I need to go ahead and copy this and paste it in here. And then the last thing is a redirect URI. So I need to set up a redirect URI for my application to go to localhost. So let's just grab this guy and save him. And I'll come back over here to our application. And we need to define the authentication redirect URI. And I'll say we're going to localhost. And then I'll just save my changes. Okay, now that that's all set up, let's come back over here to... So now that we have our app settings all configured, let's come back over to our program and let's see how this works. So what I'm doing first is, like I said, we're going through and grabbing our settings. And then after that, I'm creating an instance of a graph authenticated client. So the way that this is going to work is I'm passing in that config object. This is a helper method that exists farther down in this console app. Again, I don't want to focus on the plumbing of how to authenticate and get an authenticated graph client. We're focusing this demo just on the query parameters, but you're welcome to take a look at this demo if you like. Again, this is available as part of a hands-on lab from this module. So I'm getting a reference to the .NET implementation of the Microsoft Graph SDK, and then I'm creating a request. So here I've created a request using the client and going to the users collection and saying, go create the request, storing it inside this variable. And then I'm saying, go execute that request asynchronously and get the results. And then we're enumerating through the results and writing out the ID, the display name, and the email address of the current user. Now, even though we're using the .NET Core SDK for the Microsoft Graph, I'm also writing out the raw HTTP request endpoint that I'm going to. So what we'll do here is let's come over to our command prompt and let's go run the application by saying .NET build. It built just fine, so then we'll say .NET run. And so here we go. The application, everything just ran just fine here using that ID and the client ID and the password. So you can see we've got a whole bunch of users that have been listed. And what you'll also notice here is that the request does not have any query parameters that have passed on this. But we want to go through and we want to optimize this a little bit. So let's say that I only want to go fetch just the display name and the email address. I don't care about these IDs that you see listed here. So one of the ways I can do that is if I come over here to this users collection that we have, we have a Fluent API that I can use to issue some specific, having a little bit more control over the request. So let's say we'll create a request, and then after that, I'll say I only want to select, and we'll pass in the user object, and I'll say let's go select just the user's display name and the user's email address. All right, so we'll go ahead and save that. Now, once we've done that, I then am going to, and we'll just leave it like that. There we go. Yeah, so it'll go ahead and sync up the results. Now, let's go run it this time. So this time it should add in, we should not see the ID come back. And sure enough, we don't. The ID is missing. And that's because we use the select query parameter to just say we only want the display name and the mail address. But we're still getting a lot of data here, as you can see. We don't need all of this data to show up. So another thing we can do is we can limit the results that come back to just give me, say, the first 15. So I'll do that by adding in another parameter here. And I'll say I only want the top 15 items to come back. And so with this, we'll now go ahead and run our program, our console app, and we should see a much smaller list come back. Sure enough, we do. We see a much smaller list come back. But again, we could do some additional stuff with this. Instead of maybe we don't want to sort this in descending order based on the name. So I don't want to start with, a C and an A and then mod administrator and Alex and then back to C. Let's look at the people that are at the end of the alphabet. They're always the ones that get the least amount of attention when we see data that's always sorted. So what I'm going to do is come back over here and we'll add in another query parameter here by saying order by. Oh, and just so if you didn't notice here, notice that the query parameter that was added was that top 15 was added to the URL. So let's come back over here and let's say that we're going to order by, and what field do we want to order by? Let's order by the display name property, and I want to order it in descending order. So we're going to do it in reverse order than not alphabetic. So now when I run this, we should see names that start not with the letter A and C, but they should be sorted from the back. So here we go. We have Raul and then Pradeep and then Patty, but you see that the letters are getting progressively going in descending order. And notice too that the query parameter we have $order by display name is in descending order. But again, there's even more stuff that we can do with this. Let's now filter it to where I only want people whose names start with the letter A or B or C. So there's a couple ways that you can end up doing this. One of the ways we could do this is by using a filter command. So I'm going to go ahead and comment the order by out, and let's add in the filter operator. So here you're going to pass in an entire filter string with this. So I'm going to have a couple things we want to write. First, I'm going to have a starts with, and I want to look at the surname property, and I only want people whose names start with the letter A. So we'll close that one out. Let's go ahead and copy this because we want the letter A or B or C. So now let's run this. We should only get people whose names start with A, B, or C as their surname or their last name. And again, we'll just grab the first 15. So we may not even have that many show up. And sure enough, that's correct. So you can see we have just Berger and Bowen and Brown, Administrator, Archie, Catnero, and Klein. So here in this demo, what you saw is how we can use query parameters to limit the results that come back and manipulate the results that come back. In this section, we're going to explore how you can use two query parameters to both search and include related data in Microsoft Graph requests. We're going to focus on the relationship between entities and expanding related entities into queries to limit requests, the number of requests that you'll submit, also to limit results by filtering and finding entities with the search capability. Many Microsoft Graph resources expose both declared properties of the resource as well as its relationships with other resources. And these relationships are also called reference properties or navigation properties, and they can reference either a single resource or a collection of resources. For example, the mail folders, manager, and direct reports of a user are all exposed as relationships. Normally, you can query either properties of a resource or one of its relationships in a single request, but not both. You can use the $expand query string parameter to include the expanded resource or a collection referenced by a single relationship, a navigation property, in your results. Under specific scenarios and applications requirements can result in an expensive set of queries. The expand operator can be used to expand a collection of items, saving you from issuing additional requests. Now in this example, you have requested Microsoft Graph to automatically include the children collection from the drive/root endpoint. Now this is going to include all the default properties for the collection of files and folders within the root folder of a user's OneDrive. You can further optimize this query by including a $select query parameter to only include the specific properties from the child collection. Consider the scenario where you want to get members of, say, 10 groups. Without using the expand operator, you could achieve this with one query for getting the first 10 groups, and then you can enumerate through those results where you would create 10 more requests, that is, unless there's paging involved, one for each of the different groups, to get each of the group's members. And this results in a minimum of 11 round trips to Microsoft Graph. However, with the expand operator, these 11 requests can be cut down to a single request. Another optimization option that's supported by Microsoft Graph is to use the $filter query parameter. This enables developers to limit the size of the response by filtering on specific content. This is not meant to be confused with search. The syntax for the $filter query parameter follows the format of passing an equality function with two parameters. The first parameter is the field to filter on, while the second parameter is the value to filter on. Most logical operators are supported, such as equal, not equal, and, or, not, greater than or equal, less than, and less than or equal. There's also an operator called starts with, and this is supported by most endpoints in Microsoft Graph, but not all of them. Refer to the documentation for Microsoft Graph for full details on what endpoints support this. Developers can also use the search query parameter to search for content against people and message endpoints. Search is limited to returning 250 results and cannot be combined with the $filter or the .order by operators. When searching against messages endpoint, if no property is specified, it defaults to searching the from, subject, and body fields by default. But like the filter query parameter, the search query parameter can be combined with the $select query parameter to limit how much data we get back by only including specific fields. In this second demo in this module, we want to take a look at the application that we had previously created, and I made some additional changes to it. And what I'm going to do with it this time is I have modified it so that we can go get related information. And I want to do that to demonstrate using the expand operator and the search operator. Now, in order to do that, what we're going to do is an easy way to demo this is to work with the groups collection. So groups have a child property of members, and I want to, instead of like in the slides we were talking about a minute ago, let's say I have 10 groups and I want to see all the members of those groups. I could issue one request to Microsoft Graph and say, give me a list of the top 10 groups, and then enumerate through that collection. And for each group, go issue another request to say, give me all the members inside that group. But it's a little bit of extra work that I don't want to end up dealing with here. I'd like to do just one request to say, give me those 10 groups and all their members. And I can do that. Now, in order to do that first is I need to go modify our Azure AD application and grant it another permission because I want to get group information. So I'm going to add another permission to our application. It's going to be an application permission, and it's going to look for group.read.all. So go ahead and add that permission, and again, just like last time, I will go ahead and grant consent to that permission for all my users. Okay, so now that's done, let's go take a look at the code. So how does this set up? So it's very similar to what we looked at before, except I've made really just one modification here. Notice here that I'm saying go the groups and go get the top 5 groups, just the first 5 that comes back, because my tenant has quite a few groups. And I'm going to say, just show me or go expand the members collection inside that group. And so what I'm then going to do is I'm going to walk through all the groups that came back, and I'm going to write out the group ID and the display name, and then I'm going to enumerate through the members collection in that as well. So let's see this in action. So I'll come back over here to my console, and I'll do a .NET build to make sure everything is going to compile just fine. And it does. And so then I'll say .NET run. Okay, so what did we get? So here what I've got is, you can see I'm getting a group. So this one is the Northwind Traders group. I have a retail group right here. And you can see that just a little bit of indentation, I'm writing out the ID of the members and the member's name. And so then I have all the members in this other group. In the leadership group, we've got a few people as well. And all the way down to the legal team group, we have 3 people. How did we do that? Well, I went to the groups endpoint. I said I only want to get the top 5. We saw how to do that in the last demo. But then I'm also adding in this expand operator. And what that expand operator is doing is it's allowing me to just go fetch to go add in the members collection as something I want it to include in that request. All right, so that's a pretty cool little feature there to be able to go get additional information. Now, another thing we can do is we can look at the search operator, and the search operator lets me go find specific information. Now, to demonstrate this, I'm going to go use the Microsoft Graph Explorer. So I'm going to go to graph.microsoft.com, and I will choose the Graph Explorer. So what do we want to do here? So what I'm going to do is, you can see that I have graph.microsoft.com v1/me is my default request that I can have. And so let's go ahead and let's just run this query, see what comes back, and you can see that I get information about myself. All right, so the Graph Explorer is assuming that I'm logged in, or it's using a dummy user to automatically log me in to show me some data. However, I can, if I wanted to, go sign in and be authenticated to grab that information. So let's go through and let's do a couple more searches here. So I can do a search for me, and then I can also look for me/people. And if I run this, I can see I'm getting a lot more results. So if I scroll down, we can see a whole bunch of results are coming back, right? But I'm seeing some like coming from address of sales, right? And that's not really what I'm interested in. I'm really looking for, let's say, a specific person. So why don't I go ahead and use our query parameter of $search and do a search for someone whose last name is Wilke. And then I'll run the query. So now when I run it, you can see that my search results came back with a much smaller result set. You can tell my scroll bar here is much smaller. But you can see that I looked for someone named Wilk, and I found someone because his last name is Wilk, or his surname is equal to Wilk. Remember from the slides, I said that if you do a search for someone, it automatically searches their name, their display name, and their email address. Now, one of the other things that's neat about this, about searching, is that I can also use wildcards. So let's say I don't know how to spell their name, and I'll just do the WIL star. And we may see this scroll bar get a lot smaller when we do this request, because we may be getting a lot more results. And sure enough, we did, but not as many as we did the first time we ran it without running the search query. So there's Nestor Wilk. Let's scroll down a bit farther. There's Wilbert. That would not have shown up in the first request because we were looking for WILKE, and now we're looking for WIL star. So you could use this same search parameter inside of the .NET SDK, or right on the URL if you're working with the direct REST API option for Microsoft Graph. So I just wanted to show you two different ways that you could use this. In this section, we're going to look at how we can optimize applications that have complex or numerous interactions with Microsoft Graph by batching requests. Many complex scenarios can involve complex interactions with the data exposed via Microsoft Graph. For instance, consider an application that needs to display 3 different types of data from Microsoft Graph. The $expand operator may not be sufficient as the data is not directly relatable, or the queries would get very complex and expensive. Another scenario may involve multiple write operations, such as preparing for an event by saving resources to a shared OneDrive folder, creating a shared OneNote notebook for the event, and then sending meeting invites out to all the participants. Applications can often get quite chatty very quickly, which can also introduce potential throttling issues. One way to avoid any issues and to introduce an optimization is to group multiple requests into a single request to Microsoft Graph. Now, when I say single request, I don't mean that we're going to group all these into one specific request. What it means is that we're going to have multiple requests, but we're going to send them in one round trip to Microsoft Graph. This support, called batching, is going to instruct Microsoft Graph to execute multiple requests and then return the grouped results from each of the requests in a single response. The The requests within a batch are not special requests. They're just like any other normal request that you would submit. And because of this, all endpoints and responses exposed by Microsoft Graph can support batching. When creating batch requests, all the URLs within the request should be relative to the root of the version of Microsoft Graph REST endpoints the batch is submitted to. One important point to keep in mind, though, is that batching does not introduce transactional support for grouped requests. Furthermore, a batch that contains 5 requests, for example, can have 3 requests succeed and 2 fail. This is considered a successful batch request, as the request and responses are not malformed. Now, all batch requests must be submitted as an HTTP post to the graph.microsoft.com/v1 endpoint, and it must include the batch query operator. The requests in a batch are submitted within a JSON collection of requests within the batch request body. Unless the depends on property is defined within the request that references the ID of a previous request, the requests are not guaranteed to be executed in any specific order. Microsoft Graph determines when they are executed, which may be simultaneously. Now, each request within the batch request body is going to contain properties that define the request. In addition to a unique ID that you can assign to each request, you must include the HTTP method and the URL at minimum. In situations where you need to include headers within a batch, or in the case of an HTTP post request, you can also include additional headers and body properties as part of the request. A batch request results in a single response that includes a collection of individual results for each request. Each response object in the response collection has an ID that matches the corresponding request ID in the original request. This way, you can check the status of each request once you receive the responses. In this third demo, we want to look at how we can work with batching. And so the way we're going to do this is I'm still going to use the Graph Explorer to simplify this so we can see the raw requests that are being made. Now, to do this, what I'm going to end up doing with my request is I want to be able to issue a couple different requests. So I want to do, like, say, multiple GET requests or a create and then get multiple requests. And then I'm going to do that by using the batch query parameter. So what we're going to do first is I'm going to go ahead and sign in with an account. So I'm going to use an account of one of my sample users. I'll use Megan Bowen, and let me go ahead and get her password. Okay, so Megan has now been logged in. So a couple things I can do with this. Let's come over here and let's take a look at batch. So if I come over here in the requests and sample categories, I can find batching, and let's take a look at these batching requests. So let's perform multiple gets. So how does this work? So notice here I'm going to the v1.0/$batch, and I'm submitting it as a post request. Now the request here has got a couple different pieces in it. We have a collection of requests, and I'm going to issue a request first for all users, or for me, and just get my display name, my job title, and my user principal name, my UPN. The second request I'm going to make is going to be to go get all of my messages where the importance is equal to high, and I only want the from, subject, and receive date and body preview of those emails. And then the third thing that I want is a list of all of my calendar events. So what I can do here is let's go ahead and let's run this query. And I got the response back. So here we have our responses. Now, the way the responses work is it's going to come back as a collection, right? So I can see that everything succeeded, and it's going to come back as a collection of responses. I will have one response per request that I submitted, and the responses are going to match up. Their IDs are going to match up with the actual request that I submitted. So if you recall, the first request was to get information about myself, the person that's logged in. And that's what I got. I got the display name, the job title, and the UPN of this user. If you recall, the second request was getting information about my mail. And in this case here, we can see that it failed. So just because the request failed, or I was going to say a non-existent endpoint, or there was something else that I messed up in my query, this is demonstrating that even though one request failed, the entire batch still succeeded. So all it really means is that when you get this 200 response in a batch, it just means that all requests were successfully executed. One of them may have failed, but the response that came, the request that you submitted was valid, and the response that you got back was also valid. You need to inspect each of the responses to see if it's actually what you were looking for. The third one, again, you can see I got another 404. So we got 2 errors that came back from this, but the data was still valid. Now, another thing that we can do with this is I can also come over here and let's do another request. Scroll down a little bit. And let's do combining a post and a get request. Okay, so what does this do? This one is going to first go create a new folder inside of my OneDrive. So here, my test batching folder. So it's going to create an HTTP post to this endpoint, and it's going to go create this folder named test batching folder. Now, notice that I have this ID set to 1. Now, the interesting part about this one too is if I scroll down a little bit, what you can see is after I've done that, I'm then going to say, go get everything inside that folder. Well, there won't be anything in it, but the idea is to show you that we can run 2 requests in succession. How do I know that the second one is going to be run after the first one? Well, because I have a depends on property to say, go run query number 1 that has an ID of 1, which is what I just highlighted a second ago. Right here is ID of 1. And so now when I run this query, we can see that it actually failed. And that's because the current user doesn't have a license to SharePoint Online. So that's okay. That didn't work. That's not unexpected because this is a test tenant that I'm using here, and we just haven't assigned a license to them. But we can see that the first request did run, and then the second request, well, we got a different error there because it was a dependency that the first one failed, so the second one is not going to continue either. So in this demo, what you saw is how we could go about working with batch requests using Microsoft Graph's REST API and the $batch query operator. Thank you very much for watching this module. I hope you got a lot out of this and learned more about Graph and using and optimizing your queries using query parameters.